Today's lesson will be looking at chemistry 1502. The topic for today is alkyne reaction. We will be looking at catalytic hydrogenation, lesson 102. Let us start. Lesson 101 of alkyne reaction. We have looked at how to reduce an alkyne straight to alkane using a catalyst, specifically metal catalyst such as platinum, palladium, and nickel. Now, today's lesson will be looking at how to yield an alkene instead of an alkyne. And it all depends on the type of the catalyst we have. Sometimes this reaction is referred to a partial catalytic hydrogenation of an alkene. To an alkene. So we have an alkyne. We are going to hydrogenate it to alkene. But you should know that under alkene, it's either we can yield a cis, actually a trans or a cis-alkene. It also depends on the type of a catalyst that we have. Let us start with the cis. So if we take an alkyne, we hydrogenate it using a catalyst known as Lindlar. It's Lindlar's catalyst. Just know that it will yield a cis-alkene. That is what is important. Just know this. And you should know that to yield a cis-alkene, we have two types of catalyst. The second one is nickel boride. So sometimes you will see this as the catalyst. Just know that it will yield the very same product, which is a cis-alkene. What is important in this reaction, you should know that hydrogenation of an alkyne can be stopped at the alkene stage by using a poisoned catalyst. So these catalysts are the ones that we are going to use, which are poisoned. Remember, the difference between this reaction and the alkyne to alkane is that the alkyne to alkane, we use metal catalyst, and then to stop at the alkene level, we are going to use these two common types of catalyst, but they will specifically yield a cis-alkene. Let us look at the general reaction for this. Suppose we have an alkyne, we hydrogenate it, the presence of Lindlar's catalyst, or we can take nickel boride. We are going to have a cis-alkene. Remember, cis simply means that the common groups are on the same side. So this is the general reaction. Let us look at examples now. A quick example would be hexyne. It's actually hex-2-ine. That is the proper IUPAC name. CH2CH3. So we react this with hydrogen, hydrogenate in the presence of Lindlar's catalyst. We are going to have a cis. Remember that we are going to add hydrogens here. So it means that this part, we can put it like this, CH3, and then we have our first hydrogen here. then our second carbon, which is this one, and then the rest of this part we can put it on top also. Remember, it's a cis, and then we have our hydrogen here. So you can see that this is an alkene, specifically a cis-alkene. Before we continue with more examples, let us look at the reaction whereby we have an alkyne, whereby we hydrogenate an alkyne to form a trans-alkene. So the types of catalysts that we are going to use to yield trans-alkene, the most common ones is what we call metal ammonia reduction to alkenes. That is the process, that is the reaction that we are doing now. So we are going to use metal ammonia. The first common one is sodium with ammonia, NH3, or we can have lithium ammonia. Just know that whenever we use these, we are going to yield a trans-alkene. This reaction, it is anti-stereochemistry, meaning that it will yield groups on different sides. Now the common reaction would be to give us a trans. We cannot really say it's a catalyst because we are actually reacting this with the alkyne. Let us look at an example. We are going to have a trans. These are the carbons. Our first question. The question is, how would you, but let us do this. Let us actually write down. Remember, you can pause the video, work it out, and play the video to verify the answer. Simply write down the product. Use Lindlar's catalyst. The product will be since we're using Lindlar's catalyst, it means that we're going to have a cis-alkene. So these are the carbons. Start by writing them with a double bond in between. Then since it's a cis, let us start by putting this group here. Then we have to put this group here also. Then we have CH3. Then here we have our hydrogens. This should be the answer. I hope you got it correct. Let us move to the second one. how would you convert a pent 2-ine to a trans pent 2-ene? So let us start by writing the pent 2-ine CH2CH3, and then we have to use, since the trans, we can use lithium ammonia or sodium ammonia. Sometimes it is written like this. So these are the carbons which are involved in the carbon-carbon triple bond. So we have double bond, and this part we can put it here. Then this part we can put it here. Then we can put our hydrogens here. Let's look at our number 3. Let us look at the one whereby it has the cyclose. Okay, you can write down the product where we use Lindlar's catalyst. You can pause the video. So the carbons which are involved in the double bond are here. So we can just rewrite the ring, and then we are going to have a cis. It's your choice. You can draw it this way or this way, and this is the double bond. Remember that your hydrogens will be here. Let's look at number 4. What would be the product if we have lithium ammonia? This would actually yield a trans. This would be the carbons which are involved in the triple bond, and then our hydrogens will be here. That's it for this lesson video. In the next lesson video, we'll be looking at another type of reaction of alkyne. This is Bahula SJ. Thank you very much.